Now let's take a look at the writing the flip simulation cache onto our hard drive, and also let's take a look at the meshing our flip fluids. First, I'm going to create a very basic flip simulation. Let's create a geometry node, and I'm going to create a sphere node in here, and I'm going to just convert this into polygons and increase the frequency, because I'm going to add a mountain node in here to add a deformation onto my this source too, so that we have some of the breakups. And maybe let's also animate the noise, and let's enable the real-time playback. We have some of the animation built in, and that will create an interesting source. I'm going to use the SOP workflow for creating this basic simulation. First, we need the flip container for setting the boundaries. Let's add a flip container, and when the node is selected, I'm going to add a flip boundary node for importing our source. So let's type flip boundary and press shift enter. That will just connect all of these input. And when that node is selected, add a flip solver node in here. Let's add flip solver and now press shift enter again. And let's view our flip solver. And we need to connect this onto this geometry to source. And here you can see our source has been working and it's importing every frame. Right now it is visualized as a sprites. Let's go into the flip solver. We can go into the visualization and let's uncheck this point as sphere. I want to visualize them as these particles, and these are very lightweight to visualize. Let's add a ground plane in here. Let's go into the flip solver, collision tab. Let's add a ground plane. And we are going to move this sphere up because right now our source is just cutting off. Let's go in here and increase its size, or this center. Sorry, we are adjusting the center to add a Y offset. Let's go into the flip solver and hit play. We have this source and it is working. I can go into the flip container. I can lower down the particle separation to create more particles. Let's lower this value down to a value of 0.03 so that we are creating a lot more of the fluid particles, and here we have them. And while we are here, maybe let's also animate this source as well. Let's add a transform node, and that I'm going to add this after that. And in here I want to just add the translation onto this X direction, and I can just let me disable this DOP simulation. At the very first frame, let's start with its 0 value. Let's add a key. Let's go a few frames forward, and I'm going to move this onto the positive direction, and we need to visualize this so that I can see what I'm doing. Let's visualize, make this onto the 1 unit, add another key. Let's go a few frames forward, and I'm going to change this to -1, and let's add another key. Let's go a few frames forward and let's change this back to 0, and let's add another key. Let's go into the flip solver. Let's go back at the very first frame, enable the flip simulation, and let's hit play. And here as you can see, our source has been animating, and we also distorting this with the mountain node. And right now this fluid is moving down. Let's add a viscosity in here. I want to create a very viscous fluid. I can do so by going on to the flip container and by enabling this viscosity option. Let's collapse this and enable the viscosity, and now we can define the viscosity value in here. I can say 100. Let's start with 100 and let's see how this viscosity is looking like. We will get a viscous fluid like a honey or chocolate. And here you can see we have the viscous. I can continue increasing this. Let's change this to 1000. That way we can create a very viscous fluid. Let's say if I want to create a caramel chocolate effect. And here you can see we will see some of the layer happening once our source will go onto this side. And I think we need to also increase the viscosity even higher value. I'm going to let's add another 0 in here, and let's hit play again. And now we should start to see some of the really viscous fluid happening in here. And here you can see we have this quite hard deformation because it is a very viscous fluid. And we have this option varying viscosity. When you enable the varying viscosity, we can create a viscosity attribute onto our source. And right now, here you can see we are creating this some sort of layer type effect because we are using a very high viscosity value. And I'm going to just stop this in here. I think our animation has been stopped. Let's hit rewind and hit play. And let's see that in action. And here you can see that is our viscosity. Let's see how this varying viscosity works. If this option is enabled, varying viscosity, which means that this flip node will going to use the viscosity attribute if the viscosity attribute is present onto the source. And right now we are not creating the viscosity attribute. I can create this. Let's go into the mountain. Before the mountain, I can add an attribute noise node, and let's connect this. And by using the attribute noise, we can create a noised up viscous attribute. Right now we are using the CD. I'm going to change this to float. Viscosity is a float attribute. And in here, I'm going to type the name of the attribute that I want to create. And I want to create the viscosity attribute. And I'm going to change the range. Let's change this to 0 centered, and maybe let's visualize the attribute noise, and let's click on this to add the visualizer. And let's increase the amplitude and make sure to enable the minimum value of 0 and 1 so that our range is in 0 and 1. I can also animate the noise, and here you can see we have the animation. Let's lower down the element size and play around with the amplitude. Now that we have the viscosity attribute present, I can go into the flip solver, and here you can see this viscosity attribute has been imported, and onto the flip container this varying viscosity is working. Now this viscosity is now will act as a multiplier, which means that where we have the noise of value of 0, we will not getting viscosity. Let's hit play, and here you will see some of the part will going to be viscous and some of them will not. And that's how you can actually vary your viscosity. And here as you can see, and I'm going to just not use this. First, maybe let's hide the visualizer. Let's go into the viscosity, and let's click on this button, and that will hide the visualizer. Let's click on it, and here as you can see, now we do not have a visualizer. And I'm going to maybe let's go in here, and let's not use the amplitude value, lower down the amplitude value and make the element size to a bigger value so that we have the bigger chunk of the viscous and very smaller chunk of not viscous, the regular viscous fluid particles. Let me stop this, and let's disable this viscosity, and I'm going to go into the flip container, and let's not use the varying viscosity. I'm going to use this plain viscosity attribute that is present in here. And let's lower down this viscosity value because it is a very high value and we are not picking up a lot more detail. I think that viscosity value of 100 is fine. I can go into my source onto my mountain node, and let's play around with its amplitude to really make this interesting source. And let's go into the flip solver, and let's view the result again. And now we should see some of the details into our source. And let's say that we are happy with the simulation. Now let's see how we can write out our simulation into our hard drive, because you might be working with millions and millions of particles, and first we need to write out our caches. And after that you can add a file cache node. Let's add a file cache, and the very first is for the fluid particles. And if I were to visualize this, if I were to add a null in between, and here you can see these are the particles that we want to write, and you can add a file cache and you can do so, and that is fine. But whenever you are working with flip fluid, there is a better way to write out your particle cache, and that is first we are going to compress these particles, and that will create a very lightweight cache. And the way that we can do that is by using a fluid compress node. If you type fluid compress, here you can see we have that node. Let's add this, and we are going to connect all of them in here. And what that will do, it will going to pack our particle. Here you can see our this visualization has been changed onto box. And if I were to middle mouse button, and here you can see now we are packing our geometry. And now I can just connect this in here, and now I can write out our caches, and that will be very lightweight cache onto our hard drive. Onto the fluid compress node, here we have the particle separation. Right now it is grayed out because we are picking out this particle separation from here. And if you are working with the regular solver, let's say you have built your flip network by using the DOP, and you might not have access to all of this node, then you are going to just connect this very first input. And now onto the fluid compress node, and it will still work. It does not need to be onto the SOP level and you must connect them. You can do so. Let me undo the change. I want to remove this wire. You can do so like so, and it will going to compress your particles. But you need to go into the fluid compress, and we have the particle separation, and you must link this particle separation with your source. So you might have a source in here, let's say flip source. If you are creating a source, you have the particle separation. You can either link this from there, or you might have a flip object in here. Let's add a flip object, and here we have the particle separation. So this value must be linked with this particle separation if you are going to use the DOPNet. But we are using the SOP network, which means that this node will going to pick its particle separation from this fluid container, and we do not need to do anything, and by default it is fine. Now you can go into the file cache. You can define your location and write out your caches. And once your cache has been done, now you can convert this into mesh, because right now here you can see we have these particles. We do not have mesh. And to actually mesh this, we have a node called particle fluid surface. Let's add a particle fluid surface, and there we have it. And this node, how to unpack these particles. If you are going to use the fluid compress node and you might be working with these packed particles, you can just connect this in here, and this will going to just pick up all of our, let me connect both of them. This particle fluid surface will going to unpack our particles and generate a mesh for us. And if I were to view this particle fluid, and here you can see it has unpacked our particle and our mesh has been there. I can hit rewind and hit play, and here you will see that our mesh has been generated. And right now it is heavy because it has to calculate the mesh every frame. And once you have write out your this fluid compress these particles, and then you can add another file cache node, and this time you are going to connecting this particle fluid surface into there, and you can write out your actual mesh onto hard drive, and then you are ready to render out your simulation. Let's go into the particle fluid surface, and here we have some of the option, and we can define. Right now we are generating the polygon soup, and let's go into the filtering. We have the option to smooth out our mesh. If I were to enable the smooth, let's enable this, and here you can see I can now define the smoothing amount, and that will just smooth out all of your detail. If I were to go back, here you can see if I were to uncheck this, here you will see that we are getting all of these bumps, and if you were to enable the smooth, it will just going to smooth out your mesh, and you can define how much smoothing you want to apply. And we also have the option to dilate our mesh. Let's enable this. What it will do, it will going to expand our mesh, and it's also going to add an erosion. We are dilating as well as eroding our mesh. I'm going to, let's say, uncheck this erode. So both of these values are right now linked, and it will generate a high resolution mesh when you are working with high resolution particles. When you are working with a lot more particles, it will just even out your detail. You can also uncheck this if you don't want that. You can disable the dilate, and onto the region tab we have this container and all of these options that we are not going to talk about. Let's go into the surfacing, and in here we have the option for the adaptivity. Right now here you can see we are generating this adaptive mesh, and if you were to increase this adaptivity, here you can see we are adding more polygons where we have a lot more deformation, and we are not adding more polygons where we do not have to. And we are creating this adaptive mesh, and it is a very lightweight mesh, and all of the default values are just fine. I'm going to just change this to default adaptivity. And after the particle fluid surface, you are basically ready to write out your cache. And then after that, you can just create a null node at the end and create an a out and dive inside the LOP net and assign the material and render out your fluid simulation.